And expanding. We kind of talked through how this works. It says how fast is the surface area of the balloon expanding when the radius is 4. So what kind of a... Sorry, let's get that better. What kind of information is... this thing always does that. Thank you.
Yes.
It's like, does it worse in your class than any other class, I swear. All right, I underlined the 60 pi. What kind of information is that? It is a rate, but which one? Like, that's a pretty big part of doing this problem is identifying what that information is. Because in this case, it doesn't actually tell you. Like some of these say like the height is changing and you're like, oh, it's the height, right? It doesn't tell us that in this one. Yeah, this is, so in terms of our work, this is dv dt, okay? How do we know that? And I want you to think beyond just this problem, but like what do you look for to know it's a volume change? Because we'll have more volume changes in a little while.
It's inches cubed.
Yeah, so look for the units, right? Cubic units. Anyway, I don't know how useful a picture is going to be here. I'm going to follow the steps though. So R, we know nothing about R, right? Not generally, but specifically, maybe I'll draw that a little bigger. Specifically, the radius is 4 and dv dt is 60 pi. Okay, what's our goal? Oh, well, okay, but it gives us an equation as A, though, right? So I would say dA dt, since that's what's going to come up in the equation, like in the problem, I mean. So our goal is to find the changing area, or how fast it's changing. Okay, step 3. Well, it gives us that the volume is 4/3 pi r cubed, and also the area. So I think I'll leave the area one over here for now, just to work with it in a second. Okay, step 4 is to differentiate. So we get dv dt. That looks good, but since we were given that. 4/3 pi is a constant. And then what's the derivative of r cubed with respect to time? 3r squared dr dt. And the 3's then cancel. So dv dt is 4 pi r squared dr dt. Okay. It's looking kind of similar, isn't it, right there? Do you agree?
Yeah.
All right, so we're kind of working with two different relationships, the volume and the surface area. So what's the plan from here? Remember that I wrote in your, I don't know how many of you wrote it down, I posted it, but step 3 said be creative. Sort of, that's kind of a nice way of saying like critically think. I'll go, while you're thinking of that, or maybe some of you already know, let's go take the derivative of this one, because dA dt, that's what we're solving for. And 8 pi r dr dt for that derivative, or that to make that a differential. So how do these relate? My suggestion is this, like look at what you're given in your specific. We have a radius. Both of these have a radius, so that's that's not a variable. We know r. The only other variables in here are dv dt and dr dt. We know dv dt, so that kind of implies, hey, let's solve for dr dt. And then this will also be known, and then we can calculate dA dt. Does that make sense? Okay. So step 5 is to substitute, evaluate at that moment. So dv dt is 4 pi times 4 squared, and we don't know what dr dt is. Let me go ahead and plug in dv dt, 60 pi. Okay, so the pi's cancel. 60 divided by, what is that going to be? 64, I think. Do you guys struggle with room on these? Or do you just write smaller than me?
I think it's
Yes,
just
we struggle with
the proportion you're writing is a little different.
Yeah, I just always run out of room. So I'm going to try to combine some steps. So pi's cancel, and then 16 times 4 is 64. So dr dt is 60 64ths.
That's 15, 16.
What can we do with that? Thanks. All right, and then we'll take that and r into our dA dt. So dA dt, oh my word, just
Teachers
leave
and
us
students,
alone.
we're sorry, please disregard that bell.
No, duh.
Your weakness, right? Am I late?
No.
Oh.
I want to make sure I'm not late.
All right, now we're just at algebra. So 32 divided by 16 is 2, so this is 30 pi. And what are the units?
Inches squared per second.
Good job. Inches squared per second. Now, I don't like how I did my work. It's kind of like down and sideways and up and down, and it's frustrating. Don't do your work like that on the AP test. They give you plenty of room. My suggestion on that would be, work in columns if you feel like it's going to run out of room going downward. I kind of tried to do that, but it just didn't work. So sorry about that, but did that help? If I handed you this problem Monday on a quiz, fist to 5, what would you get on it?
Next Monday?
Yes, Monday. Okay, so most people are feeling pretty confident. Any others on this that you'd like to do or ask about?
11.
All right, the base of a triangle is decreasing at a constant rate of 0.2 centimeters per second. And the height is increasing at 0.1 centimeters per second. If the area is increasing, which answer best describes the constraints on the height h at the instant when the base is 3 centimeters? All right, picture, that's an ugly one. What kind of relationships do we have in a triangle? Yeah, these are side lengths though. But good job. He said 180, like we know the angles add up to 180. What else? And I'm going to show that this is increasing. How do we find the area of a triangle?
1/2 base times height.
Yeah. Or we could do base times height divided by 2, right? Okay. Oh my word. This is unreal. All right. Tell me about the right side. Tell me about the right side derivative. Like we need to turn this into a differential where stuff is changing. All right, 1/2. And then what's what property or rule do we have to apply to BH? Product rule, yep. Just so I don't do this again, I'm going to move this down here. It is kind of convenient, I agree. All right, so 1/2, and then remember it was f prime g plus g prime f. So in this case, let's just do d b dt. By the way, I should probably put that half outside of brackets. Okay, and then h, hold on, h plus d h dt times b. Okay. And then the base is point dh, db dt is 0.2. dh dt is 0.1. And constraints on the height h at the instant when the base is 3. All right. And then dA dt, I'm just going to say is growing. It's increasing. So what is the sign of dA dt? Maybe I'll write it that way. Positive, yep. Okay. So it says what are the constraints? I suppose we could clean this up a little bit more. Maybe. So 0.1 h plus is that 0.03, I think? 0.1 times 0.3?
It's just 0.3.
Just 0.3.
Oh, duh, it's 3, not 0.3.
And times that.
Okay, I'll just put all of that together all at once. Good idea. Okay. So now we can just, you can't really calculate this, right? I mean, I suppose you could if you subtract 0.15 and divide by 0.1. But we can also, since we have all these options, just kind of plug them in and see. So if h is greater than 3, this is positive. If h is less than 1, is it still positive? So I'm just going through the answers. What did you say? 0.1 times 1 is 0.1. Well, it says strictly less than. So if h is 0, where would that break over? Let's just solve it. You know what I mean by break over? Like you said, you put it as for a little while. So I'm saying where would it become not? This would have to be greater than 0.15, right? But negative, I mean. Like a negative value. I'm just looking at our options.
In your answer sheet, you set it equal to 0.
Well, that's because that's where it transitions. You know what I mean? From positive to negative. So, is there a way to do this? Like, let's say you didn't think of that. I was looking through our answer choices to help you with that. Because maybe you don't think of that. You know what I mean? So what would you do if you didn't think, well, let's set it equal to 0? That's what I was looking through the answer choices. And then, but that takes time. Like Trevor said, it takes time to figure out where it breaks over, like switches. What is 0.15 divided by 0.1? Is it negative 1.5? Okay. So as long as we are less than that. The big deal there is making, I think, the big deal there is making sure you do the product rule on anything that is not a constant, that it's being multiplied. We saw that, I can't remember, we saw it in the last couple days. I don't know if I'll see it right away. Yeah, it was this one. So even though the area formula for a rectangle is pretty simple, it still kind of looks worse actually when we take the derivative because of the product rule. So don't forget to do that. It's not just d L dt, dw dt. And then I guess we just did that also on the well, same with the triangle. Anyway, point is, be careful on your derivatives.
So on the 11th column, it says the base of the triangle is decreasing constant. Doesn't it mean negative?
Oh, negative 0.2. Yes. Well, it doesn't change the whole process. Good catch. I just read right over that. There we go. Is that better?
And also, how do you know if it's less than 1.5?
Well, for that, so she's asking, like, we have two that have the 1.5. So how do we distinguish between which it is? What do you guys think?
Just sign it again.
So in that case, I would just pick an easy number that falls within that. This is an interval, right? Like starting somewhere and going, or coming from somewhere and ending. So pick an easy number in there and see if that actually would be true. Or maybe two numbers, like negative 10. Like for this one, two easy numbers might be like negative 10 and 0. Or not 0, but negative 2. And then here, well, 2 and 10 maybe, right? And compare what happens to the area. Make sure it's positive. Does that make sense? So use the calculating to narrow it down, and then in that case, just check. All right. Did anybody do this one? It didn't have a key. Let's check it. How do we, so it says the particle is moving along the x-axis given by this position. A is a positive constant. For what values of t is the particle moving to the right? Well, how do we know when t is moving to the right in general? Or p, excuse me, our particle, when it's going right? Yeah. So we have to know which sign, the sign of the velocity. So how do we get velocity for this thing? First derivative, yeah. Okay, and then how do you do the derivative of that one? Okay. So I'm going to just pull the 1/2 for a second, and then 2, and then inside a minus t, and then chain rule. A is a positive constant, so its derivative is 0. But t, what's the derivative of a minus t then? Okay, so let's clean this up a little bit. And we'll get negative a minus t. Okay, and so that only occurs when, so that's our velocity, and this particle is moving right. When negative a minus t is greater than 0. And then solve. I hate scrolling back and forth, but I feel like it's too small. Can you guys still, that's probably okay size, right? Can you still see that? How do we solve that? A is a positive constant. How do we solve? Yeah, you could, or just divide it, like divide by -1. And then add your t. So, which one is that?
Oh, you divided by -1.
Hey, good job. I never forget that. That is annoying. Good job. Guys, these kinds are not really related rates problems. Like notice we never, we didn't relate more than one rate. We just had the velocity. So it's, it's related to related rates because we know that this particle moves right or left based on what sign its velocity is. But it's not that we're trying to solve another rate given a rate. So we're not relating two rates. Does that make sense? Okay, let me show you another one. You probably saw that a little bit ago go by. Let's just talk through this one. I'll let you read it though, so take a second to read it. Yeah, this is in your packet too. Do you have your packet?
Where is your top from?
Huh?
Where's your top?
What do you mean? Oh, yeah. It was not a whole costume, but do you know the quote? Negative Ghost Rider?
Yeah, top right.
Maybe we just
It was kind of a little bit of a mess. So,
because I saw it in some of yours, all your stuff.
yeah. A few of us did, and then other ones did superheroes. So, just, I don't want to sign in, so just go. All right, everybody have a chance to read it? So, the graph represents what? Remember, when you're given a graph, go label that this is a velocity graph. Or if it says, like, down the road, if it says this is f prime, not f, or whatever, go ahead and label that. Okay, it says the graph of the particle's velocity is shown. Which of the following expressions gives the total distance traveled by the particle over the time? What the heck? How do we find total distance? It did say it has the position function x of t, right? So when is it moving? It says total distance, which means like based on the graph, at some point it's moving right, some point it's moving left. So total distance would have to account for direction as well, right? When is it moving right based on this graph? Yeah, so in here it moves right, and then over here it moves left. And again, this is velocity, which doesn't tell us how far it's moving. The position function does, x. So which one of these options is telling us the total, considering we're moving right and left during the 5 seconds? Well, let's just take them one at a time. What would this first one say? X of 0 minus x of 5. Is that even a valid one? No, because it's backwards anyway, right? Like it starts at 0 instead of 5. Just to remind you, this is like x final minus x initial, right? So that one's backwards. Okay, part B, does it account for everything? No, because why?
Because
It's like treating the whole motion as one sign, right? All right. So thinking like test strategy, we've narrowed down to at least a 50-50 shot at this point. Okay, part C, x of 3 minus x of 0. So that's good. That would tell us this piece. So x of 3 minus x of 0 would be which direction? Well, that's where it moved to the right. Plus x of 3 minus x of 5. That's this one. But why does it say plus?
Add the negative.
Yeah, it's doing the minus negative thing, right? Technically. Note that the direction, or the order rather, of the two numbers is the wrong way, right? But that's why we changed the sign. So this could say minus x of 5. I'm going to do it slightly. Well, I'll do it the same as them. Minus x of 5 minus x of 3. That's the way that we should write it because that's final minus initial. But if we flip it, now we can say plus because this result would be the opposite sign of the one given. Is everybody following what I'm saying? In other words, if we read it backwards. Okay. So C, the difference between the C and D is that the on the D, the left one is switched around. So C is good. Yeah. There's a little bit of twists and turns in there that you have to be careful with. Okay? How do you feel about these kind? They're not in your packet other than the copies I made. Does it seem okay? You want to try one before we do another related rate problem?
Yeah.
Do you have this one? Okay. Why don't you give that one a shot now that you've seen? What? Can you go what?
Can we team up?
Yeah. Always.
Yeah,
If he wants to. Yes.
I'm gonna go to the CO substation. Her house is a metric figure out. So you can share that fun math back.
Okay. Thanks.
If the calculator problems,
Screws and well, I need to learn the French response to that. I don't know what it is. Just while you're working, letting you know this, I was preparing our test for this unit yesterday. There's a lot of FRQs on this one, FRQ questions. So be practicing these like kind where you work them out, including this one. Even though it's multiple choice, there's a fair bit of work involved to get there. You guys have a direction for it? Huh? Why do you do that? Just say what you're going to say. Have you ever heard this phrase? If it's worth saying once, sorry, let me get it right. If it's worth saying once, it's worth saying twice. If it's not worth saying twice, it's not worth saying once. So, there you go.
that's the third time. So what does that mean?
I don't know what you mean by it. If we look at these last two, they're the same in terms of a structured approach to the problem. So like the first one, we found the derivative. If we're given the position, get the derivative or find the derivative. Oh, forever fighting that. This time, in the first one we did together, we had to find the derivative. We calculated it. In this one, we were given it, but we still needed it first. Everybody good on that? Okay. And then you're going to calculate when the derivative is positive or negative, depending what it's asking. So in this case, this first one, it asked when is it moving to the right. So that was positive. So depending what is asked. So right, remember that means positive, and left means negative. And then on this second one with the graph, we still did that. We figured out where it's moving right and left. It was just given graphically instead of we didn't have to go solve an algebraic statement for it. But we figured out it was moving right and then left and used that for our total. So apply that same strategy. Find the derivative. This one it says at what time t is the particle's position farthest to the right. Find the derivative. Moving to the right, we have to make sure that that is positive. So we set it greater than 0. That's how we write that in math, right? Greater than 0.
I'm confused. 'cause
Okay.
the position graphs apply to the derivative.
Well, because how do we know when it's going to the right or left? If we're just told the position function, we don't know, right? Huh? Does everybody understand what I'm answering in response? Like a position function, if we graphed it, then sure, we could, if we could graph the position function, we might be able to tell, but we don't have a graph, right? So how do we know when the particle's moving left or right to know when it's the most left or right? Yeah.
When x prime of t is above 0.
So that's, yeah, if it's positive, it has moved to the right, and negative moved to the left. Okay. Should we do another one then? You want me to do this one with you so we don't spin our wheels? Yes or no? All right, be careful on this derivative. What kind of situations do we have in there? Thinking like rules, properties, that kind of stuff. What do you see? Chain rule for sure. And what else? Nope. Product rule is in there. And then, of course, the derivative of E, which is what? All right. Product rule is because if we zoom in, right in between there is a product of two functions. Okay? So what's the derivative of t? It's just 1, right? Because this is all with respect to t, so it's just 1. And then I think I'll just write e to the negative at. Okay, so that is f prime g plus, and I'm going to use a bracket because we know the chain rule is coming up. So this is going to have two pieces. Okay, now we have f, and then we've got to do g prime. I guess I don't need the bracket just there, but this will help clear up what we're doing. So this is f prime g. Now we're about to do f g prime. Everybody clear on where we're headed? So f is just t. What's the derivative of outside function e to the at? Or negative at, excuse me. Yep. So e to the negative at times, now we do chain rule. What's the derivative? Like, what are we chain ruling? Actually, let me ask you that before I tell you. What are we applying the chain rule to? Negative AT, right? And A, it told us, was a constant. It says A is a positive constant. So negative A. Everybody good on that part? Okay. So dt of negative a to the t is just negative a. So that's kind of like piecemealing our chain rule up here. Outside function, inside function. Okay? Now, certainly we would like to clean this up some. Minus at e to the negative at. 8. Yeah, I was just seeing that. Okay. So there's our derivative velocity. And what has to be true of it? Okay, it has to be greater than 0 for it to be moving to the right. Okay, what's a good step to solve this? What was it? Yeah, you could do two things. Like you could factor out e to the negative at and get 1 minus at. Or you could do what he said and like add 1 over and divide it off. Okay? But either way, do you see we're going to get 1 minus at greater than 0? Are we all good on that? You know what? Maybe I'll just show it because I see some faces. So if I add this one to both sides, we'll get e to the negative at greater than at e to the negative at. And then we can cancel these. Okay? And that will leave us with 1. Good? And then we're solving for a. So are we solving for a? No, we're solving for t. So t and 1 over a. So just divide by a. And that one is b. Okay. Are you kind of seeing a pattern here? Okay. Do you guys... What time do we get out of here? Okay. All right, flip to the... See if you have this next one and flip to it. Okay. I don't know how you'll feel about this. Like there are FRQ related rate problems, and then there are kinds like this. It's a related rate problem that you do the work for and then just pick an answer. So the reason I'm bringing that up as a separate issue is because you have a lot less time on these on multiple choice, right? And a no calculator multiple choice is an average of 2 minutes. So this is a related rate problem in 2 minutes or less kind of idea. Now, of course, we know that some problems are shorter, so you can bank time and maybe save up. So this problem has 5 minutes to do. But just understand that's tough, right? That's a hard thing. I'm going to push you from now till the AP test that your bread and butter are the multiple choice questions. Okay? If you can rock that section, I'm not saying that you just blow off FRQs at all, because you can still get a lot of points there. But they're hard, right? FRQ problems are hard. And they usually put one on the calculus test that's like very few people can even solve. Like they're tough. One of them. And so if we can do really well on the multiple choice, which should be a good plan because we have the answers there, right? Which provides verification, then we're pretty good. I think we're better off. So tell me about this one. Think about taking like a bike tube if you've ever done that, or those exercise bands or tubes. Like when you pull them, what happens to the diameter of the tube? Yeah, like it's skinnier, right? Same even with the rubber band. They're just not cylindrical. So this tube is being stretched while not flattening out. It's staying cylindrical. The height is increasing. So we're given a height. What in terms of our probably what we know is coming in our problem, how would you label the height change? What would that look like in our problem? It's a rate of change. So what would we label it? D what? Yeah. And I think as you go, especially on these multiple choice, just highlight and start naming things. So at a rate of 2 millimeters, that's a height. Oh, that's dH/dt. Okay. At the instant that the radius of the tube is 6, is that a rate? No. So I would maybe write in there R equals 6. Okay. The volume is increasing. Oh, that sounds like it's changing, right? So what is the 96 pi? That's dV dt. Okay, so we're starting to see pieces that are going to be in our equation down the road. Which of the following statements about the surface area of the tube is true at this instant? Am I in your way? Probably, let's see. Here would be my strategy doing this problem. It says which of the statements is true. I'm going to glance down here, and it's all of them say increasing or decreasing. So that is what in terms of our equation labels. Area increasing or decreasing. What does that look like? dA dt. Okay? So that's probably our goal, dA dt. Looking down at the choices, it's not asking for an area, like just a value of area. It's asking for a change in area, a rate. So it's dA dt. Okay? And then it gives us some relationships that they don't necessarily expect you to remember. This looks kind of weird. It looks like some SOF kind of thing. It makes me think of like SoFi Stadium for some reason. It's just a typo. It shouldn't be jammed together. Okay, so what do? You guys want a minute or two to set it up? Some of you might have already been.
Probably not 6 or 7. Probably not 1 or 2.
At least have a strategy. Like, come up with your strategy that you're going to try on this one. You guys have the Ferris wheel problem in your packet, I think?
I think so.
Yeah.
Yep.
And then do you have the cone problem? Yes. Okay. Okay, do you have a strategy? I just want to get you on the right track before we have to leave. Raise your hand if you do. Okay. So most of you, I think. All right. Here's kind of the idea. In a cylinder, what is true? This one isn't true actually anymore. Never mind. 2, so pi. There we go. Oh, come on. Do you wish you could do that, Trevor?
Maybe keep printing it where we're putting it.
I know. Well, it's because I realized it was going to be too small. Or there wasn't going to be enough room.
Doesn't that whole thing just become zero?
Become what?
Zero, or the first half, yeah.
First half and second half of what?
Of that specific derivative. Is DRDT zero?
Well, it's if you're stretching this, it's the radius is changing.
At that instant.
Yeah, so he's asking, does the radius change? Do we have to account for dRdt? Well, it's asking at that instant, is the radius changing at that instant? Well, how do I say this? It wants dH dt, so it's assuming that the height is changing. But it doesn't tell us anything about a rate of change of r. Does everybody understand what I mean by that? Like dr dt. Like we have no information about that. Let me update my derivative here real quick. Because r times h, that's product rule. If we're taking the derivative with respect to time, right? So this is times 2r dr dt h plus r squared dh dt. And I put brackets because pi was out front of both of those. Okay, so writer is proposing that this term, if that's supposed to say dt. If dr dt is constant or not changing, then that would be 0, right? What do you guys think? In the first term, 2r dr dt h, that's in product rule terms, that's f prime g. Do you guys think dr dt is constant?
Just the way it's worded.
It does, huh? Yeah.
Like it's a cylinder being stretched vertically.
Okay, I'm going to do the s derivative up here. Again, we have that, so dr dt h plus r dh dt. And we're about to run out of time. So I'm going to table that one and we'll pick it up Monday. In terms of work, I want you to work 2 problems for the weekend. Give this a shot. In your packet, you have the cone problem. And it looks like this. Let me tell you one piece that you need to know. This is like if you take half of this cylinder and make it look like we swept around a triangle. As we go up and down in terms of volume level or height of water, just hold on one sec. The relationship between the height and the radius stays constant.
Students,
Okay.
if you're dressed up for Halloween today, we'd love to have you stop by the concession stand. You will receive a free popsicle. So if you're dressed up, come on down to the concession.
So what's the relationship as it's given? Do you see how the radius is half of the height of the whole cone? I mean, okay, and that's going to always stay true. Like even if we were way down here, hardly any water in there, the radius of the water would be half of the height of the water. Okay? That's a critical piece of information. That's called similar triangles. Do you remember that from geometry?
Yeah.
Okay? That's a critical piece of information to do this problem. Otherwise, the rest of it runs fairly similar to what we've done. So I think I'll just let you try that one, and then I'll post one on Google. So look on Google for the second one. Have a good weekend. Be safe tonight, or whatever you do.
Wait, Mr. Atkinson, at 7 a.m. I almost got hit by a truck.